Hi everyone, I am François Goudunov from the Commercial Department of Syntony. Thanks for attending this session. This is the third time that we make presentation to FPST conferences, but this year we see in our discussion with many different potential customers that tunnel GPS coverage is becoming more and more a requirement, even in the tenders. And it is a requirement for safety-related application in most of the cases. And this is the objective of our presentation, to talk about this. GNSS help people and save lives. Our company is, and our job is to make GNSS work everywhere, even underground. Syntony is a young company, but it's a spin-off of another company with more than 20 years of research and development in GNSS. We are based in Toulouse. We have some offices in America, and we have a distribution network all over the world to address different countries and different projects. Our expertise is in GNSS signal processing. We are expert in software-defined radio solutions. We address different markets, like a rail market, but IoT also, or space market, transportation systems in general. And we are providing different types of products. We are providing simulators, and we are providing receivers. We have many different customers all over the world, private companies and state-owned administration or agencies on different markets, as you can see on this slide. There are many different GNSS applications for safety, but I'd like to highlight some cases that we are discussing with many customers. One is about emergency call location. Now the regulation are asking more and more for the handset, which is passing the emergency call to locate itself. And most of the time the location must be done in GPS coordinates. This is the case in the United States with 911 calls, but also in Europe with 112. So GPS is important to locate the emergency calls and help better organize the emergency and rescue operation. Fire rescue is also more and more based on GPS for protecting the firemen, the fire brigade in operation. And even in very smoky conditions, you need to know where your people are. And in case there is a problem, you can locate them because you get their GPS coordinates. Automated vehicles, connected vehicles, will be more and more implemented in the transportation system, and they are considered to be part of safety improvement as compared with human-driven vehicles. And I'd like to highlight a specific concept, which is track platooning. We have been working in September this year on a platooning test. So platooning concept is like forming a virtual train of different tracks, each one being enslaved, digitally enslaved to the previous ones. And with such a system, I mean, you can reduce the incident risk in a tunnel, because all the tracks will be enslaved to the first one with a specific pilot who knows very well about the tunnel and who will take care of the full platoon inside the tunnel. there will be a creation of a digital link between the different tracks inside the tunnel, and the asset management, the system coordination is taking into account GPS and GNSS location, but it has to work in the tunnel for that. So GPS, GNSS will be also very important for ensuring the seamless operation between the outside and the inside. All the platoon operation will be referenced in a single system. And we did this test in a very well-known tunnel, which is the tunnel of the Mont Blanc, and between France and Italy. Several partners are involved in this project. The leader of the project is the Tunnel du Mont Blanc. ST Telecom is a partner providing radio communication solutions. Syntony, okay, we are part of the project. Ecotrans is a group of transporters, sort of unions of transporter, cooperative. And it is part of a big project which is called European Track Platooning Challenge. We did some tests, and we don't have the result yet, but we made a lot of recordings with no automation yet, but we will use these records to prepare for the next steps. It was very important that it took place in the tunnel of the Mont. More and more activities rely on GPS, in fact, to support location services or navigation or safety, or even to save cost. And the problem is that in underground areas, GPS is not working. Our system, Subwave, will provide an answer to this and is a solution to make it work underground. And providing GPS coverage inside the tunnel will help working with a very robust and universal position system. And all the systems which are working with GPS will work inside the tunnel with no update or no upgrade. I mean, they will natively, they will be working with GPS coverage. This kind of system will provide a seamless transition between outdoor and indoor operation. So there is no specific system to be defined because you are under the ground or under the tunnel. And you can even imagine that there are different levels of services, with standard services or more precise and more accurate location for some dedicated service. So there are many ways to implement GPS-based services inside the tunnel. And we know that it won't interfere with other radio frequency systems because, I mean, GPS frequencies are dedicated and they are reserved for GPS system. And finally, it is very updatable. I mean, you can update it easily for future evolution. How does it work in underground areas? Okay, the key point is GPS is considered as a commodity by everyone. So the idea is that we will provide access to GPS services as if it were outside. And for that, we have developed a technology with a computer that can simulate the GPS signals as if they were emitted from the satellite, and we generate that simulation inside the tunnel. The main characteristics of this system is it will provide a perfect emulation of the GPS. I mean, it can work with any different types of GPS receiver, a smartphone or Tetra or professional receiver, IoT devices, trackers, everything. It works because the GPS signals are identical to the one you would receive from the satellite. depending on the level of accuracy, it is possible with some specific receivers to get accuracy up to 2 meters. And one of the key characteristics is that there is a continuity of service. When you come from the outside world and you get the real satellite system, and when you enter the tunnel and you get the simulated signals, I mean, there is transparency and continuity of service. It's really seamless. It provides XYZ coordinates, so not only XY coordinates. So if you have different levels of tunnels, you can know exactly where a person is located if you can get its position. And it is cost efficient because the system will use and will reuse the existing radio infrastructure. GPS signal is just one radio signal on top of the other ones. So that are the main characteristics of our system. Let's have a look at how does it work. Okay, in most of the tunnels there is what we call leaky feeders. It's a radiative cable used for the radio frequency system. It is available already in the tunnel, and we'll connect our system to this cable through a coaxial cable or a fiber optic cable. And most of the time we also connect our system to a GPS antenna outside of the tunnel in order to get synchronization with the true GPS constellation. And then every system which is working with a GPS chipset will capture the signals and will be in a position, will be able to compute the position. Typical length of leaky feeder that we can address with a good accuracy is about 300 meters. So with one subwave computer, we can address 6 different zones of 300 meters. So it means one subwave computer can address a little less than 2 kilometers of leaky cables. So where do we stand today with GPS coverage, tunnel GPS coverage? There are many different projects, in fact, which are underway or which will start very soon. In many different countries, there are several different use cases that these projects are addressing, but all of them have a link with safety of operation. And if the safety is not the primary use case of a given project, it is not very far. It's always very, very related to the project. We have been working with road tunnels in Northern Europe, UK, Spain, France, Italy. We are also working on different projects in Australia. And we have been making a result project in Japan. We also have several projects in discussion in East Asia. And there will be a tunnel in Canada using GPS coverage in Montreal. There are also rail tunnel, and here again, many different projects in Northern Europe, UK, Spain, France, Italy, same. Australia, Japan, East Asia as well. And we are more and more involved in mines and the mining environment, and with also a lot of tunnels. And we have different projects and discussions in Northern Europe, but also in Africa and South America. So we tried to describe very briefly subwave and how it can fit with safety operations in tunnels. It's now time for the questions, so we are happy to get your question and provide you with some answers. Thanks a lot, and don't hesitate to contact us if you need some more details and information.